Today you're going to learn about vectors. You're going to learn about what happens when a particle moves along the xy plane given its position x with respect to t and y with respect to t. For some reason, Oline thought that parametrics in and of themselves were difficult. This may be where he got that idea, because vectors are a little bit more difficult than parametrics, but even so, they aren't difficult compared to some of the things you learned in pre-cal. I mean, about parametrics and vectors. Take your derivatives, then you need to define your velocity vector. It is extremely important that you define your velocity vector. If you would like me to describe some drama that occurred last summer around the grading involving the velocity vector, it involves 2,000 calculus teachers in an uproar because they believed that you should not have to define the velocity vector. I will do that in the next step. There you go. There's the velocity vector. I don't know what else the velocity vector could be. Neither do thousands of calculus teachers around the country, but it needs to be defined as such. Find your velocity in this particular problem, then find it for the particular value of t. Now find the acceleration vector. Remember to define acceleration as the second derivative of x with respect to t and the second derivative of y with respect to t before you actually find the value. And voila!